This integral makes the best use of Legendre's duplication formula. But before we begin with this integral, it's necessary to know what Legendre's duplication formula is. So basically, if we have a gamma of g plus 1 by 2, if we have a half over here and this g is a positive integer, yeah, in that case this will be equals to 2n factorial by n factorial times 4 to the power n and root pi. But many of you might not have seen this formula in the form that I have been telling over here. Basically, we also have another form, yeah, where we can manipulate this. Basically, we can write 2n factorial as 2n times 2n minus 1 factorial, yeah, and then n factorial as n times n factor 1 minus n minus 1 factorial, and then 4 to the power n will be 2 to the power 2n and root pi. Now we can basically cancel the n and take this 2 and subtract over here. That gives us gamma of 2n by gamma of n to the power 2n minus 1 times root pi. So this is also another form for Legendre's duplication formula, but this is the most convenient one, and we will use this formula in this problem. Okay, now let's enter the integral and let us see how this can be used. First of all, we can see that e to the power minus t and root t, these things are leading to let's say gamma functions definition, but over here we also have cosats of a root t. So for that we can basically use the infinite series expansion for cosats, and that will simplify the expression. Okay, now the infinite series expansion for cosats of x is sum from n equals to 0 to infinity x to the power 2n by 2n factorial. So this is the infinite series expansion. Now we can use that. We have integral from 0 to infinity e to the power minus t, t to the power minus 1 by 2, and then infinite series expansion from n equals to 0 to infinity. We have a root t to the power 2n by 2n factorial times dt. Yeah. And now since the series is always positive, we can exchange the sum in the integral. Sum from n equals to 0 to infinity, integral from 0 to infinity e to the power minus t, t to the power minus 1 by 2, a to the power 2n, t to the power n by we have 2n factorial, nice, 2n factorial dt. Now we can take the constants out of the integral and then take the integration. We have sum from n equals to 0 to infinity, yeah, and then take the constants out. Constants are a to the power 2n and 2n factorial. Now if we take this out, we will have integral from 0 to infinity of e to the power minus t, t to the power n minus 1 by 2 dt. Okay, so now this kind of matches the definition of gamma function. So basically we have gamma of n is equals to integral from 0 to infinity e to the power minus t, t to the power n minus 1 dt. Now if there's n minus 1, we have gamma n, yeah, so here's n minus 1 by 2. So this is basically n plus 1 by 2 minus 1, so we will have gamma of n plus 1 by 2. Yeah, let's use that. Sum from n equals to 0 to infinity a to the power 2n by 2n factorial, and then this will be gamma of n plus 1 by 2. Now in this case, now we can use the Legendre duplication formula for gamma of n plus 1 by 2, yeah, and that helps us a lot. Sum from n equals to 0 to infinity a to the power 2 to the power n by 2n factorial. So basically you can also find this in a real intuitive way as well. You can just go down, 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 and then basically you will reach gamma n by 2, and there comes root pi. Yeah, so you can do it without the formula as well, but formula makes the life simpler. Yeah. Oh yeah, if you don't want to use formula, you can just do like n minus 1 by 2, yeah, n minus 3 by 2, n minus 5 by 2, and go on till gamma 1 by 2. Yeah, and that way also you can do. But let's use formula for now. We know this is 2n factorial by n factorial, and we have 4 to the power n and root pi. Yeah. Now the 2n factorial cancels out. We are sorry, and we are seeing that the terms are getting simplified now. We can take root pi out of the sum because it's a constant, and we have sum from n equals to 0 to infinity. Now we can write this as a square by 4 to the power n. Yeah, a square by 4 to the power n by n factorial. Now this might look similar to you because we know sum from n equals to 0 to infinity of x to the power n by n factorial is e to the power x. Yeah, this is the Taylor expansion for e to the power x. So if we use that, this will be root pi times e to the power a square by 4, and this is the answer for the integral root pi times e to the power a square by 4. So this integral was not that hard, just using the expansion and the interchanging the expansion and using duplications formulas. Yeah, or you could have created the formula yourself as well. And yeah, in this way we solve the problem. Yeah, but in this problem we can see that duplication formula was clearly really helpful. Yeah, there are other cases as well where it can be helpful. For example, if you have to find the value for some expressions like 1 by 4 plus 1 by 2, in that case also, no, not really. Other there might be other cases. Yeah, for example, for gamma 1 by 4 as well, it might be helpful some way to find gamma 1 by 4. Yeah, and yeah, there are other such cases where this formula can be helpful. And hope you enjoy the integral, and thanks for watching. Look forward to seeing you in the upcoming videos too.